Welcome to the chapter Heat. This slide presents the overview of the chapter. Learning objectives. By the end of this chapter, you will be able to describe temperature and heat, explain the concept of thermal equilibrium, discuss about kinetic energy, explain the concept of specific heat, list the applications of specific heat capacity, state the principal methods of mixtures, explain the processes of evaporation and condensation, define humidity, fog, and dew, differentiate boiling and melting of substances. Introduction. Click each tab to know more. In lower classes, we learned that heat is a form of energy in transit, flowing from a body at higher temperature to a body at lower temperature. The concept of hotness and coldness using glasses filled with cold, lukewarm, and hot water. We also learned that hotness and coldness are relative terms. Heat is a form of energy. Are the terms temperature and heat technically the same? To answer this question, let us do some activities. Let us know about hot and cold objects. In our daily life, we see that some objects are cold like ice and some objects are hot like tea. We also know that some objects are hotter than others, while some are colder than others. Commonly, the degree of hotness or coldness of an object can be estimated by using our sense of touch. The hotness or coldness is expressed in terms of temperature. But estimating temperature with our hands can sometimes mislead or confuse us. Let us perform an activity for relationship between temperature and heat. Take a piece of metal and a piece of wood. Place them in a fridge or in an ice box. Take them out after 15 minutes. Now touch them to feel their coldness. Heat transfers from the fingers to the wood and metal pieces. Remove the fingers from the substances and the feeling of coldness ceases. The feeling of hotness or coldness involves transfer of heat from the substances to the body. Here, the metal piece is colder than the wooden piece. It is because the degree of coldness of the metal piece is greater than that of the wooden piece. The term, the degree of hotness or coldness, is defined as temperature. Finally, in terms of temperature, the metal piece is at a lower temperature as compared to the wooden piece when both of them are taken out of the icebox or fridge. Thermal equilibrium, heat and temperature. Transfer of heat takes place when two bodies, one hotter and other colder, come in thermal contact with each other. This process continues till both the bodies have the same degree of hotness or coldness. At this point, we say that the bodies are in thermal equilibrium state. In the state of thermal equilibrium, a body neither receives nor emits heat energy. Example 1. When no transfer of heat takes place between you and the surrounding atmosphere, your body is said to be in thermal equilibrium state with the surrounding atmosphere. Example 2. Similarly, a furniture in a room exists in a thermal equilibrium with the air in the room. Here the air and the furniture in the room are in same temperature. Here, we are going to discuss heat. Generally, when we stand near fire, the heat of fire enters into our body, we feel hot. In the same way, when we hold the ice piece in our hand, the heat is transferred from our body to the piece of ice and we feel cold. Hence, we can conclude that heat is a form of energy in transit. It is always transferred from an object at a higher temperature to an object at a lower temperature. Definition: heat is a form of energy which makes an object appear hot or cold. Take two empty cups or vessels or mugs. Fill them with hot and cold water respectively. Now take a laboratory thermometer. Observe the initial level of mercury in the thermometer. Note down the reading in your notebook. Place the thermometer in hot water. Observe the change in the mercury level. Note down the readings in your notebook. Now keep the thermometer in cold water. Observe the change in the mercury level. Note down the readings in your book. We observe that mercury level rises in thermometer when kept in hot water. This implies that heat was transferred from hotter body, hot water, to colder body, mercury in thermometer. Similarly, in the case of cold water, we observe that mercury level comes down from its previous level. The reason is that here the transfer of heat takes place from mercury, hotter body, to water, colder body. From the above activity, we learned that heat is a form of energy in transit. It always transferred from a body with higher temperature to a body with a lower temperature. The steadiness of the mercury column of the thermometer indicates that the flow of heat between the thermometer liquid mercury and water has stopped. That is, thermal equilibrium state has been attained by the water and thermometer liquid mercury. The reading of thermometer indicates the temperature at which the thermal equilibrium state is attained. Thus, temperature is a measure of thermal equilibrium. Thermal equilibrium with three bodies. Now, let us learn about the thermal equilibrium with three bodies. Consider two different systems A and C in thermal contact. These systems are in thermal equilibrium individually with another system B. If system B is in thermal equilibrium with system A, then both systems have the same temperature. Likewise, system B and system C have the same temperature. So the systems A and C will also have equal temperature. In this way, the systems A, B and C exist in thermal equilibrium state with each other. After learning to measure the physical quantities, temperature and heat, let us learn about the units used to express the measurement of these physical quantities. The SI unit of heat is joule, CGS unit is calorie, CAL. The amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius is called calorie. 1 calorie is equal to 4.186 joules. The SI unit of temperature is Kelvin, K. It is also expressed in degree Celsius, C. The degree Celsius is converted to Kelvin by adding 273 to the value of temperature in degrees Celsius as per the relation 0 degrees Celsius is equal to 273 Kelvin. Temperature in Kelvin K is equal to 273 plus temperature in Celsius. Until now, we learnt about temperature using larger bodies. Let us learn about temperature at molecular level through activities. The following table shows the differences between heat and temperature. Knowledge check. Attempt the following question to check your understanding. Take two bowls, one filled with hot water and the other with cold water. Gently sprinkle some food color in both the bowls. Observe the motion of small grains of food color. We notice that the grains of food color exhibit jiggling movement, that is, they move randomly. This is the result of the random motion of the molecules of water in both the bowls. We also observe that the grains of food color have more jiggling movement in hot water than those in cold water. We know that every moving body has some kinetic energy. As the particles, that is the grains of food color in both the bowls move with different speed, are said to have different kinetic energies. Finally, we can conclude that the molecules or particles of the hotter body have comparatively larger average kinetic energy than the colder body. In this way, the average kinetic energy of molecules of a body is indicated by the temperature of that body. In other words, the average kinetic energy of the molecules is directly proportional to the absolute temperature. Let us do another activity to learn more about the relationship between temperature and kinetic energy. Take a jar half filled with water and heat it to 60 degrees Celsius. Take a cylindrical glass jar which is transparent and fill half of it with hot water. Now pour some coconut oil over the surface of the water very gently, such that the water and oil do not mix. Close the jar with a lid containing two holes. Take two thermometers and insert them into the jar through the holes in the lid. Put the thermometers in such a way that bulb of one of the thermometer is inside the water and the other touches only the coconut oil. Now note the readings of both the thermometers. The mercury level in the thermometer kept in water falls, while the reading of the thermometer kept in oil increases. It is because the average kinetic energy of the molecules of oil increases, while the average kinetic energy of the molecules of water decreases. In other words, the temperature of oil increases while the temperature of water decreases. Some heat energy flows from water to oil. As a result, the kinetic energy of the water molecules drops and the kinetic energy of the oil molecules increases. In this way, Water loses energy while oil gains energy due to the temperature difference between them. From the activities 2, 3 and 4, we learn the following differences about heat and temperature. Heat is the energy that flows and temperature is the quantity which decides the direction in which heat energy flows. After learning this, let us now learn how these quantities are associated with a system through the concept of specific heat.